Hello scholars, welcome. Mr. Hinkle here, and in this short lecture we are going to discuss Earth's energy. So where does Earth's energy come from? Well, the primary source of energy on Earth is the sun. Earth does have internal energy from the cooling of Earth's core is releasing radioactive energy, radioactive heat as it cools, but the primary source is energy from the sun. And so this is what we're really going to talk about today. Now, the sun transmits energy through heat in the form of radiation. And that radiation arrives on a spectrum of wavelengths called the electromagnetic spectrum. Excuse me. Let's do Earth here. And this is not to scale because the sun is not smaller than the Earth, but just for instance. So, sun's hot, real hot, releases heat. That heat travels through the exosphere, arrives to Earth via radiation through different wavelengths. And what we see is the visible spectrum of light. It's light in a certain wavelength that has color that our eyes have been evolved to comprehend, to interpret. So let's talk about Earth's energy budget. It's a budget, it's balanced. Someone's doing really good with their bank account here. Earth, spot on. Not saving any money, but also not going into debt. The budget is balanced, where we have 100% of the solar radiation that leaves the sun, right? That makes sense, 100% leaves. Well, of that 100%, 47% actually makes it to Earth. The rest of it is reflected or scattered or absorbed. Now, this 47% of solar radiation that makes it to Earth actually leaves Earth also. So this is in perfect balance. That's why the Earth doesn't just heat up continuously. There are slow changes to climate, and we'll talk about that. But on a regular basis, the Earth isn't just in a direction where there's more solar radiation coming in than solar radiation leaving. This is called Earth's energy budget. The incoming heat equals the outgoing heat. Great. Now, the outgoing is going to be through conduction to the air, latent heat, which is the absorption by water, and then this part, long wave radiation, which is basically the heat that is absorbed by the Earth is re-radiated at a different wavelength. And it's going to go a little bit like this. So we'll just, hopefully you've written this down. You've got this note. This is the energy budget. It's also here. Shortwave radiation from the sun. Right, so I'm going to erase the budget. We're going to say, okay, this is balanced. I kind of want to leave this long wave. So 100% here, 47% makes it. The wavelength of light that makes it to Earth is shortwave, which literally means the wavelengths are shorter. And then that shortwave radiation is absorbed by land and by water, and it is emitted back to Earth as infrared radiation or long wave radiation, which is going to be wavelengths that are a little bit longer. Okay, got it. Now, long wave radiation is absorbed by particles in the atmosphere called greenhouse gases. When long-wave radiation is absorbed by greenhouse gases, it is re-radiated back down to Earth, where it is absorbed once again by water and land, where it will now re-radiate back into space to be absorbed by the greenhouse effect. Now, the amount of times light will absorb, it usually happens at least once, but it can be multiple times before that heat escapes back out into the atmosphere for that balance. But this is wildly important because if there were not greenhouse gases in the atmosphere, then all of the heat being emitted from Earth would escape, and Earth wouldn't have a regulated global climate that would sustain life. So this phenomenon right here, which we have just discussed, this is the greenhouse effect. The greenhouse effect is a natural atmospheric process that is absolutely crucial for the habitability of our planet Earth. Now, the greenhouse effect is impacted by the excess burning of fossil fuels leading to global climate change, which we will discuss in another lecture, but for our purposes here, this is the science behind what's happening. Shortwave radiation from the sun is absorbed by the Earth. It is emitted as long-wave radiation back into space, where it is absorbed by greenhouse gases and re-emitted back down to Earth. It's called the greenhouse effect because this is what happens technically with a greenhouse. Heat from the sun travels through the windows, heats up the inside and everything inside of the greenhouse, and then as that heat tries to escape, it's trapped in by the windows. Now, there's no greenhouse gases in a greenhouse, obviously, and so it's not a window around the Earth, and a little bit different things are happening, but the concept is basically the same. Okay, so primary source of energy is the sun, but it's not the only source of energy. We've also got Earth's internal heat from the cooling over time. The Earth was hot when it first formed. It was super hot, and as it's cooled, it stratified into a core mantle crust. Earth's internal structure by composition. I gotta draw this one up here. This is my favorite thing to draw. Core mantle crust. And since that time, it's been continuing to lose heat, and that heat transfers through the mantle in convection cycles, which is in part a driving force, the mechanism of plate tectonics. Earth's energy budget is balanced. The amount of incoming heat equals the amount of outgoing heat. The primary source of Earth's energy is the sun. There's also energy from within the Earth, but it's much smaller, negligible, about 5%. So we really want to focus on the sun. And within this energy budget, the key player for our Earth system, for understanding climate, is the greenhouse effect. Thank you so much. See you again.